Hello everyone. Welcome to Singapore Geospatial Festival 2021, an event that brings the international geospatial community together for co-located activities, promoting the use of location-based and mapping innovation. So this event is organized by GeoWorks, Singapore's Land Authority Geospatial Industry Centre. So today we are excited to introduce the speakers from Mott MacDonald to share with us more on applying GIS in engineering projects, some of the case studies that they have. So if you have any questions during the webinar, please leave them in the Q&A chat box and we will answer them at the end of the webinar. So thank you, and without further ado, I will hand over to the first speaker, Fabian. Fabian?
Thanks. Hi, everyone. First, I will talk about Mott MacDonald. So, Mott MacDonald is a global engineering, management, and development consultancy. It employs about 17,000 staff in 150 countries. In Asia Pacific, we are about 1,300 employees. Sofiana, which will do a presentation later, is based in Malaysia. John and myself are based in Singapore. Here are some great outcomes we've helped our clients achieve. So for the first part of this session, I share more about integrating photogrammetry in geotechnical workflow. In the geotech industry, part of our work is collecting data to determine site conditions to design infrastructures such as roads, dams, or buildings like an airport. Site investigation is time-consuming, especially for large projects, and when those projects are overseas, it also gets more complicated. So, in the context of the pandemic, when traveling and interaction are limited, it was even more essential to find alternative solutions for site investigation. With Mott MacDonald, one alternative that we explored was drone survey and photogrammetry. Photogrammetry is the construction of an image in 3D based on multiple photos taken from a drone. Taking photos with a drone is efficient. You can cover about 25 hectares in 1 hour in good weather conditions, and you can capture informations in previously inaccessible areas. Because it's so easy to deploy a drone and capture photos, you can do this on a regular basis, every few days or weekly. And with this, it will give you images that show your site progress over time. And with a wide bird eye view from the drone, you can show the entire site captured in a single moment. Your scenes are frozen in time. To build your 3D model with photos, you have to take multiple photos with the drone of the same location, but from different directions and angles to improve the accuracy of your model. By overlapping all of these photos and using the drone GPS coordinates, the modeling process, known as aero triangulation, begins toward constructing your 3D model. However, as the GPS is not the most accurate technology to capture coordinates, the accuracy is about plus to minus 5 meters, I suggest that you have ground control points on your site that can also be captured in your photo to adjust your model later. Here, on the left image, you can see the position of the drone in yellow and the process of aero triangulation overlapping photos. On the right, you can see the green circle that shows the coordinates determined by the aero triangulation, while the red circle shows the exact location. So the difference is only a few centimeters, and it shows that photogrammetry is able to georeference your photos in 3D accurately. The result of aero triangulation is photogrammetry, and it's a 3D model of your site. Not only you can navigate through your site, but the accuracy and the quality of your model allows you to do site investigation. I'm going to share a video with you. On this video, unfortunately, I am not able to share the entire site, but here is just an outcrop, a geological formation. So this is the result of our photogrammetry. So you can see it's a 3D model. You can navigate through. And if you look closely, the quality is impressive. You can easily see all the different geological layers that we found on site. You can even see our ground control points that we use to improve the accuracy of our model. Back to my slides. The video may have been a bit laggy, sorry. But here are two images of the same video, and you can see the high quality of our photogrammetry model. As these models are numeric, you can easily draw lines, polygons, to identify the varying geological sequences for your study. As it is also numeric, by drawing these lines and planes, you can identify faults, joints, and discontinuity and measure these angles, which is really important for our site investigation. Additionally, more output files can be created from the model, such as reality mesh, point cloud, and contour lines. These are standard format in the geotech industry for your survey. With these files, you can combine your photogrammetry model with other models, such as a beam model, a geological model, some boreholes, and many other layers. So here is an example of our geological outcrop that is combined with a beam model, a tunnel, and you can also see some boreholes. We are using context capture for photogrammetry, which is part of the Bentley software family. But as mentioned, all of these file formats can be easily integrated to other softwares and shared with our clients as well. So this is really easy for use, and your clients and colleagues can also have access to these beautiful models. Here is another video. You can see the result of the photogrammetry model that was used with another beam model, which is here a bridge. And additionally, we have combined our geological model. On top of this, you can use virtual reality for an immersive experience. You can basically be virtually on site while physically be in the office or at home. And here you can see Regilia, one of our geologists in the Singapore office, which is doing site investigation and trying this new feature. So drone survey and photogrammetry is time efficient. Your scenes are frozen in time, and things that you've missed before can be easily retrieved. This is safe to use, especially for areas that you cannot access. We have used this on some of our overseas projects. This technology can be used for other contexts beyond site investigation in geology, and we hope to use it very soon for more projects. However, you might encounter some limitations with drone usage, as licenses are required in some locations when it comes to drone permissions. So make sure you know country regulations before you using it. Of course, like any technology, there are other considerations, such as getting the right equipment and software to support photogrammetry. Overall, it's a great tool. So I'm happy to take questions if you have any at the end of this webinar. Thank you. Now I will pass the presentation to Jonathan that will talk about Moata and future cities.
Thanks, Fabian. If you could stop presenting and then I'll take over. Okay, great. Just get that set up. So thanks very much, Fabian. Yep, so my name is Jonathan McCallum. I'm a senior consultant here at Mott MacDonald. And today I'm going to be talking a little bit about Mott, which is our digital twin platform that integrates GIS, and the Future Cities project that we've been working on over the last 18 months now, predominantly the Iskandar Malaysia SIMS project that I've been working on a lot. So the Future Cities project, just to give you a bit of context here, it's part of the UK government's Prosperity Fund, and the idea is to carry out targeted technical assistance to support sustainable urban development in a variety of locations. So the total of 19 cities across 10 countries worldwide. But in Southeast Asia, we're working in Malaysia, the Philippines, Thailand, and Indonesia. And the projects that I'm working on have been things like in Bangkok, we were looking at a rainfall gathering system to improve predictions for floods. Indonesia was a transport system again. And the one in Malaysia is specifically about urban and transport planning. I'm looking predominantly at the Iskandar Malaysia project, but there's also a second project in Malacca as well. So the Future Cities has 3 pillars or themes to it, going across all of the projects worldwide. And these include urban planning, so trying to promote transit-orientated development, looking at affordable housing and disaster resilience. And then coupled with that, the two are often intertwined quite closely, is transportation, and looking at getting sort of cost-effective, safe transport methods available for the public. And then finally, resilience. So, with climate change and environments moving forward, we need to consider how both urban and transport planning can be made more resilient for the future. And in particular, we're looking at the sort of GESI groups, so looking for gender equality and minority groups that could be exposed to all of these different detrimental factors. The Iskandar Malaysia job or project had 2 interventions, and the first is the implementation strategy for a smart integrated mobility management system, or SIMS. And this is predominantly to help address mobility issues by providing solutions, and that can be in form of a technical solution as well as capacity building within the country itself. But looking mainly to enable evidence-based urban and transport planning. So moving away from a certain amount of sort of guesswork and estimation based on anecdotal evidence, and moving to data-driven decisions. So collecting the data that we need, processing that, and looking at how systems are actually working based on the data rather than just on humans' interpretation of what they're seeing day to day. So that's the SIMS project, and part of that is also to provide guidance for the future investment. Obviously, it's to have an integrated mobility management system is a large undertaking. We have to stage that as we move through from where they are currently, with different systems on the ground, and integrate those into a combined system. And the other, which is sort of coupled to it, is creating these enabling conditions for data utilization and management. And again, coming back to doing evidence-based urban and transport planning. So building that capacity within Iskandar Malaysia to use these different technologies and perform data analysis so that they can do these spatial and transportation plans in the future. So I'll focus mainly on intervention 1 today, which is the SIMS project. So just to define what it is, Smart Integrated Mobility Management System. So in terms of being smart, we're looking for these data-driven decisions, as I sort of mentioned earlier. It's supposed to be integrated. So, this isn't just about, say, public transport. It's also about the private transport, but a whole range of data sources as well out there that could impact both urban and transport planning. And the point is to try and gather all of these different data sources into one place so that an urban or transport planner can utilize that and make their decision based on the data that's now available to them. We've actually sort of expanded it to say that the way the system would work would allow applications to be built within it, and so it's actually going a little bit further than necessarily being just a mobility management system, but at the moment we're targeting just that. So mobility is obviously the focus on transportation, but it's not just about getting from A to B. We need to look at the access to different forms of mobility and the affordability. So looking back at those sort of GESI factors that we need to take into consideration. In terms of management, obviously they need the short-term control, sort of traffic lights and information on the roads, for example, but also the longer-term strategies for planning. Do we need a new route for the buses in a particular place? Do we need a new road? What about our green spaces around the urban environment? Have we got those in the right places? And finally, it is a system, and that's very important, that it's a combination of the data that we're collecting as well as software. It's not just a single standalone piece of software. We're going to have multiple different applications or even systems sat within this ecosystem that are all sharing data. So our scope at Mott MacDonald was to develop the concept design for SIMS and then deliver a pilot which would focus specifically on urban and transport planning. And so that's really what's taken up the majority of my time in the last sort of 9 months. So to give a bit of an overview of the architecture for this, as I mentioned, SIMS, we see it as an ecosystem of applications. And the idea being that using API connections, the application program or protocol interfaces, we can share that data across a common or standardized data channel. And then the different user groups will have different applications for their own specific needs. And the example that I've given here are 3 different applications that we see could be within the ecosystem. So the first is a traffic management application. There's various different tools out there for monitoring traffic, so using ITS or intelligent transport systems in order to gather all the data about what's happening on the roads. And the main users for that would be traffic controllers. But there's data in there that will be useful for other people. And so there'd be a form of aggregation of that data because we don't need the absolute real-time data. And that will be fed up to this common standard channel that then the other applications can draw the data down from. And so on the right-hand side, there's a journey planning application where a member of the public can go onto that application and plan their journey from A to B, and get feedback on the things like costs and timetables and things like that. But at the same time, that's where utilizing the data that's coming from the traffic management application would be useful, because there might be a traffic jam at some point on the route that they've selected. And so algorithms in the back of the journey planning application can make adjustments on the fly to take that into account and suggest an alternative route before the person has left their home. And both of those sets of data will feed into a transport modeling application. And this is where transport planners would benefit. And they would use this in order to examine the historic data, so travel habits of the public, so using the information for the journey planning app, as well as all the information that's being gathered about the road usage and volumes of traffic on the road and different modes of traffic that then go into their model, where they can then start to produce scenario plans. And those scenario plans could then be fed back to the traffic management application, such that if there is a traffic jam at a particular location, then a set of scenarios can be looked at and decided which one should we use in order to alleviate that traffic. And on top of all of that, there'll be other data sources as well. So we can connect to other data systems such as the Skandar Malaysia Urban Observatory, which is collecting other data that's useful as sort of context these other applications may find to be beneficial. So as I said, we built a pilot within Mott in order to facilitate a rapid turnaround. And Mott is MacDonald's digital twin platform, and it's based around GIS. This just allows us to sort of share ideas with the client in order to be able to work out what their desired functionality for SIMs may be in the future. We don't actually have to build SIMs as part of our remit. It's just to start collecting those ideas to go out to tender for somebody to provide it. And what we did do with all of this is largely follow the UK government digital services principles on developing these sorts of systems. And there's a few interesting ones in there, such as designing with the data in mind, making sure that everything that you're conveying is good information. But perhaps the most important one is the principle of doing less, which I sort of like. The client was a bit perturbed by this, what exactly that means. But quite often with smart cities and things like this, we end up trying to do too much as a sort of platform provider. And so there's cases around the world where a government has come in and said, right, we're going to do absolutely everything in here, and almost shut out the community. And that's detrimental because you don't get adoption of the system and it doesn't grow in an organic manner, and eventually just nobody's using it, and so it's useless. So by doing less, what we're suggesting there is just providing the platform and the APIs such that other community users can come in and build their own applications into the system and generate that sort of community interest. So there are three main stages that we went through, data collection being the first one. So there were a lot of data sources that we had a look at, trying to pull those all together. And we were really targeting quality data, but more of a case was what data was actually available. This is quite a stumbling block we found in doing this. There are now, of course, issues around data privacy, and we needed to make sure that that wasn't going to be an issue. So data security was paramount there, as well as data sovereignty. There were certain data sets that are governmental, and they've said, well, these need to stay on servers in Malaysia, and so that needed to be taken into account when we're looking at sort of hybrid systems for cloud storage and things like that. But what we were very adamant about was sharing data as opposed to sort of copying and dumping the data in a new system. And that's where those API links come in. We want to make sure that we're not duplicating data, but having the data on hand when it's needed in order to do analysis with it. So these data sources, we did not too much processing with. A few of them we needed to manipulate just a little bit to get into the right format. But generally, it was just a case of plotting these up onto the GIS. A lot of them were already in shapefile format or formats that were amenable to use within the GIS. And as I said, the main challenges that we had there were the data. Some of the data formats we did need converting. We also had dynamic data, and so setting up APIs in order to load that dynamic data, such as the weather. And then in some cases, we just didn't have the data that we needed in order to sort of fulfill the pilot objectives. And so we had to use synthetic data in order to sort of fill that gap. So one example of that was the ITS data from the traffic management system. Iskandar Malaysia didn't have a full-blown traffic management system at the moment, and therefore there was no data available for us to do that, but we needed it. The next step that we took was to do data derivation. And so what we're looking at here is we've got all this raw data, but you know, what are the metrics that urban and transport planners are particularly interested in? And so we targeted over about 150 different metrics, looking at a wide variety of international papers that have been written on this, and looking at the sustainability development goals from the UN. And we couldn't do all of these metrics. We just didn't have the data that was available. But I think we got down to about 40 out of maybe the 300 in total, which wasn't too bad as a first pass. And what Moata allows us to do is embed reports, these you know, business intelligence reports, so that we could not just do a sort of spatial visualization through the GIS, but we could also look at breaking that data down into more granular sort of components in order to explore the data in other visuals. A big issue around this was the granularity of data. You know, we broke this down using the MUKIM within Malaysia, but you know, eventually there will have to be some decisions taken around that as to whether that granularity is too high or too low, and decide how to move forward with it. So we produced dashboards for 5 different areas: transport planning, urban planning, economics, environment, and quality of life. And a lot of those metrics were all around kind of proximity to transport nodes. So how far am I from a bus stop? What's the population within 400 meters of a bus stop? And it's looking at walkability, essentially, in order to make a city more sustainable. And then a final step that we took at this stage was to add some more advanced analytics. And this was basically adding functionality to leverage off that raw and derived data. So we did 3 main items. One was the petal scores, which is a public transport accessibility level. And what this does is an algorithm basically to give you a spatial score for every 100 by 100 meter square within a region as to how good the accessibility to public transport is. The next one that we introduced was a bus route assessment tool. And so we allow the user to be able to draw a route and then push that through an algorithm using all the derived metrics in order to develop a score overall for that new route based on accessibility and affordability. And the idea being there that then people can benchmark against other routes and maybe set levels to whether or not a route is acceptable or not. So to help the urban and transport planning. And the final one was some sentiment analysis. So Sofiana is actually going to talk about a citizen's complaint or feedback portal that we developed as part of this. And what the sentiment analysis was doing was taking all of that data, making sure it's anonymized, and then looking for the hotspots of where particular problems are. And in the future, the idea would be that you can then cross that with other data and do some machine learning on it in order to predict what sort of conditions are likely to lead to more complaints and how that can be addressed. So I wanted just to give a quick demo. If I come out of here, see if I can do this. So this is the Mott platform. I mean, it's very familiar for anyone who's using GIS. You have a set of layers, and these can all be expanded, and you've got all your different layers down there, and the map. So what I've got turned on at the moment is the live data sources, and for example here I've got air quality. And what our system allows us to do is actually to chart this data up and start looking at all the information that's contained within that particular item. And I can turn on more data here. There's little bits of functionality on the graph that I can turn on. And then I can also do scatter plots where I can plot one metric against another and start looking for trends over time. I can switch the graph back and forward on a time series sort of thing. So a really nice sort of tool combining different aspects built straight into the GIS sort of platform. And so one of the things that we were looking at was like bus routes. So if I turn this layer on, we've got all the bus stops, and I've themed this up by the number of trips daily for all these different bus routes in here. And one of the things that somebody might look at is the IMUO data provides us with some census information. So this shows us the sort of density of population across the region. And what we might want to do is start examining some of this bus route information and where we might like to plan a new route. And so using these petal scores, we turn that on. And so you'll see a sort of 8-bit type of map up here. So these are all the petal scores coming in. So the red showing where you've got good connectivity, and the gray areas or the blue showing where you've got poorer connectivity. And this tends to get a little bit busy. And so one of the features that we've got in here is we can fade the different layers out, but I can also add that layer to a swipe tool. And so this now allows me to start looking at, that I've got a high density of population sort of in this area here, but no bus routes there. So, that's maybe something that I need to have a look at. The petal scores are relatively low, even on the main road. But once I come off that, there's very little there at all. So these are some of the things that we were able to do. And in the reports, we've got the route analysis tool here, which brings up all the different metrics that we've got around. Just takes a second to load. So, for a particular route, we get an overall route accessibility index score, an availability index score, and these are some of the different metrics that we're using in order to calculate that score. And then we generated a table overall to sort of give a heat map showing you how your different routes are compared to your the different parameters that we've used in order to generate those scores. So that's just a quick overview there of the system. And really what SIMS is moving towards a digital twin, where it allows the ingestion of data from a physical system, or actually a number of physical systems. And then we can perform calculations with that and analyze the data. And from that, we can actually generate the data-driven decisions rather than using that anecdotal feedback that we rely on quite a lot. And then implement those decisions in order to improve the urban and transport planning outcomes. And we looked at a few different sort of use cases or problem framing exercises. And, the most obvious one is congestion. So, if you do some root cause analysis on congestion, there's all kinds of reasons as to why congestion might occur. But if we're starting to collect the data, we can actually check those hypotheses that we're putting forward and then test those with some proper modeling to see what's happening. Some other items that we were looking at were public transport use. So why, how do we encourage more use of public transport? And then road maintenance as well. I know there's a lot of problems in Malaysia with potholes. They sort of makes the press quite frequently. So what can we do in order to look at the road maintenance and improve how that's all working by gathering the data, looking at maybe the complaints data that's coming through, doing some root cause analysis of what we anticipate being problems that are causing the potholes, and then build models around that in order to do better predictions. So that's the end of my presentation. So Sofiana is going to talk about the complaints or citizens complaint portal that we put together to help collect some of this data that will feed into SIMS in the future. So I'll hand over to Sofiana now. Thank you.
All right, thank you. Thank you, John. So yeah, I will start my presentation. All right. Good afternoon, everyone. My name is Sofiana. I'm from Malaysia, GIS engineer from Mott, MacDonald's, Malaysia. So I will proceed with our ways of adapting GIS configurable apps for community and for project data collection that mainly focus on our Iskandar Malaysia's SIMS project. So there are two configurable apps that we have created in order to help us and our stakeholder to capturing a new data and also validating our existing data. The first one is the citizen feedback portal, which are more focusing on the collecting the new complaint from the citizen in Iskandar, and also the second apps is special groups data validation apps. It is focusing on the validation data of the cycling data and also the people with disability groups data. For example, like all of the facilities, whether it is and whether it is good or not for the disabled people. So first, let me just introduce the background of why we proposing these apps. Because our stakeholder, they have their own existing system to capturing all of this data, but the existing system does not have any geospatial information. So we need to go through a lot of data processing in order to transform this data from table form to GIS form. So yeah, it would take a lot of time for us to complete the process. So we propose these apps in order to hope for them to receive the data in GIS format rather than the previous format. And also the in the current system, the administrator cannot change cannot customize the visualization of the information. They can only display information according to one field only. For example, they want to do some analysis for a pothole in certain location, but in the current system they are not allowed to do that because there are no functionality like that in the current system. Yeah, and the third reason why we're proposing these apps is because yeah, it takes a lot of time to extract and convert the current data from the table data to GIS format in order for this data to be used in analysis. So yeah, we're proposing this citizen feedback portal. It is created in their existing software. So yeah, the aim of the apps is actually to overcome the limitation of the existing system, and to improve in the future data collection method, and also to facilitate the task to provide the alternative way for the stakeholders in collecting data to directly in GIS format. Apart from that, we would like to produce the data display that combine the spatial database and also the attributes database. And we hope that these apps can give the stakeholder to manage a way to manage the complaint better by visualize the data in the better format and easy to understand for the administrator. So next slide. Okay. So there are three components of the citizen feedback portal app. So the first one is the apps itself for the user to submit a new complaint or contributes to the existing complaint. The second one is the dashboard itself. It is to stakeholder and us to manage the current complaint and also to filter out some of the information and to visualize the KPI of the stakeholder officer. And the third one is the feature service itself. It is to for the stakeholder to keep on updating the data, the status of the data, and append a new data. All right, so this is the workflow. The first one is the preparing data. As mentioned by John before, our data granularity is focusing on MooCAM. So there are three type of data template that we need to prepare. First one is the data from the existing system, from our stakeholder existing system. The second one is the administrative boundary, consists of the polygon layer. And the third one is the MooCAM boundary, which is a polygon layer itself. And once we publish that to the our GIS database, we use that to create the citizen feedback portal itself, and the user can use that to collect the data, whether it is a new data by choosing the category and then fill in the information and then submit, or they can choose the existing, choose to contribute to existing data by clicking the category, and then the list of the complaint 300 meters around them will be appear, so they can just click on that and then click on vote to increase the priority of the case, so that the and so that the stakeholder can notice that uh, other than the other cases. Okay, the outcome from the apps is we separate into three groups, which is the community, the stakeholder, and the our project team itself. So for the community, this apps is really help in notifying and visualization the complaint to their current close to their current location, since the apps will shows a list of the existing complaint found 300 meters around the area. And also for the stakeholder, these apps will be help in to facilitate the task and provide the alternative ways to collect the data in the future. And also the dashboard itself can help in the expedite the process of analysis and identify the location of the reports, and also managing the KPI of the officer handling cases and keep track all of the aging cases, for example, and visualizing the combined info that I mentioned before in the form of dashboard. So for our project team, these apps is really help us in expedite our data processing, since we it's already in GIS format, so you don't need to do some extracting or processing of the data. And this data will be used in our Moata Smart GIS, as been mentioned by John before. The second apps is our community initiative. It is for targeting to the cycling and people with disability groups. The background is actually as we would like to gather more data for our SIMS project, we noticed that some of the stakeholder does not have any database. They don't have any platform to gathering the data, and they don't really have the data template or data itself. They are not collecting any data. So our initiative to provide the ways of how they can capturing the data and gathering the data by creating these apps. So other than that, they can also validate our current data that we have. Yep. And then these two apps actually allow the user to capturing point, line, and polygon real time on the GPS of the mobile device. So the aim of these apps for cycling apps is actually to validate our cycle track to the and the facility of the cycling facility around the Iskandar area. For example, like pit stop, yeah, cycling track, yeah, and all of the activities that can be carried out during the cycling activity. For the PWD group, people with disability group, our aim is actually to crowdsource the data from public, especially from the disabilities group. It is to capture the information of the existing facilities like public toilet, ramp, bus stop, and other, and whether it is friendly or not for the disabled group. Okay, so as for the outcome, yeah, we separated into three groups, which is community, stakeholder, and project team. So for stakeholder, they mentioned that these apps has really helped them to keep track the previous cycling activity and the future cycling activity within the group, since before this they are not collecting any data. Yeah, for our project team, is really help us in validating our new data, and yeah, to and facilitate our task as well, since yeah, it is already in GIS format, so we doesn't need to do anything. We just need to send the data to our relevant team to for the analysis. And for the community, yes, same as the previous apps, it helps in visualizing the facilities around them, which close to their location, 300-meter around their location. And also, yep, this facility include all of the public toilet, bus stop, and etc. So this is the data visualization. Nothing much to cover actually, since our data visualization is actually more in Moata, as been mentioned by John before. So all of the data that has been collected will be combined together in order for us to better analysis the quality of life in quality of life dashboard. So as a conclusion, we receive a very positive response from our stakeholder by creating these two apps. They mentioned that these apps really can overcome the special weakness of the current system, and the targeted groups that using our apps is from 12 to 40 age group, and no conflict of redundancy with any existing current system. So, and the data visualization using the dashboard, it's really help in managing the complaint strategically. And for data collection teams, we found that it is really helpful for us to speeding up in time taken for us in data extraction and conversion. And yeah, all of the data will be directly used in our Moata Smart GIS, since it can be read in Moata as well. So yeah, it really help us in yeah, facilitate and better analysis to determine the impact of the facility problem in our study area. Yep, that's it from me. I'm happy to receive any question from you. Back to you, Lim.
Hi. Yep. Okay. So I think we have one question. So perhaps now I can show on the stage. Yeah. How comprehensive and accuracy of the geotechnical info can be made available for design purpose? Anyone from the team would like to answer?
Is it related to the photogrammetry, maybe? If I just take the photogrammetry modeling example, the accuracy is it really depends on how many photos and how many ground control points you have. The accuracy is a few centimeters. I will not recommend that for a topographic survey, for example, when you need to have an accuracy that can be a few millimeters. But it's just to give you an overview of your project and sites and do some site survey. So if you don't need to be that accurate in terms of millimeters, centimeters is still fine. Meters is great. And if it's to have a look at your data on site, photogrammetry can really help you.
Okay, thank you. Is there any other questions from the participants? Yeah, I think we have one more. Yes. Is it Sims application commercially available?
Sims itself is not commercially available at the moment. What we're doing is we're building the specification basically for it. That was the purpose of the project with the pilot in order to demonstrate what could be done. What is obviously commercially available is the Mott platform, in which we could build the Sims if we wanted to. That's we're not looking necessarily to utilize Mott as the platform for Sims. It was purely used as a sort of example of what could be done.
Okay, thank you. So I think so far there isn't any more questions from the Q&A segment. So we have come to the end of the webinar. So thank you everyone for tuning into the webinar. So before you go, please check out our events. Yeah, here. Yep. Before you go, please check out our events by scanning the QR code and joining the conversation using the hashtag SgGeoFest. So thank you, and we will see you again.
Thank you.
Thank you.